Hello everyone, my name is Phoenix and in this video we are going to solve our next CTF challenge WE10. So it says that we are tired of WE9 and they have created a better version that they are calling WE10. These are our starting conditions where the contract has 10 ethers and we will start with 1 ether, and our job is to basically drain the ether present in the WETH contract to ourselves. This is the foundry setup, and we have to start with an address called Bob that has 1 ether, and we have to end this test by claiming all the ETH present in the contract. So as usual, I have copied all of it into my local development environment. Let's see how is this working. We have a basic implemented ERC20 contract from OpenZeppelin, one fallback function that calls the deposit. We have a function called burn all that burns the entire balance of message.sender. We have a function called deposit. You can call this deposit function to mint WETH. We have a function called withdraw and withdraw all. Now both of these functions are working in the same way. The only difference is that the withdraw all function just calls the burn all function that burns the entire balance of message.sender. We also have a new function called execute that is used to request a flash loan in ETH. So basically this is the entire contract. I've copied the entire test scenario that we have been given. So this will be the attack idea. We will first start with Bob. We'll deploy our exploit contract, which I'll come to later. Then, so here is the thing. What we can do is we can approve. We have to first call ourselves and approve an infinite amount of tokens to execute this attack. And after that, what we are going to do is like this. We'll call this attack function. So first what will happen is there is a for loop that will execute until the balance of the WETH contract is 0. We'll call the deposit function. The deposit function, after it's been executed, we'll call the withdrawal function. As soon as this is being called, the send value, which is, if you don't know, is a function in OpenZeppelin contracts that executes. The problem with this call is that it is a lower level call, and so all the basic assertions to prevent reincidency is not there. And if you can see, even OpenZeppelin wants us to sort of check the implementations where there is no possible reentrancy vulnerabilities. Now this is the classic example of how even putting a non-reentrant modifier to all of your functions cannot even save you from the reentrancy bug, because the modifier works in a way where as soon as the execution of that particular function starts, the reentrant modifier change its states from 1 to 0 or 0 to 1 in general scenario, and then it changes its state to normal only after the execution of the particular function is ended. And so you cannot just re-enter into the same function. However, you can re-enter into a different function, and that is what we are doing. We'll first call the withdraw all after the deposit, and so this withdraw all will call the send value to our contract. Now this is the time where the control flow is in our hands, and so what we'll do is we will trigger the fallback function that will transfer the 1 ether to a third address called Bob. So we have 3 addresses here: the address of WETH, the address of this test contract, and the address of Bob. Now the burn all function cannot execute further since we have pulled out our 1 ether. After all of this has been done, we'll call the transfer from function and then pull our one ether from Bob to this address. Then we'll call this call dot value on Bob with all of the balance of the contract. This will be done again and again until the entire balance of this contract has been collapsed. Now let's see if all of our attack has been consistently done or not. So in the test app function, what we'll do is we'll deploy this our attack contract. Then we'll approve the exploit contract with almost infinite amount of tokens. And then we'll call the attack function that we have created. So let's just start forge test. As you can see, our test has been successfully created. There's one thing that you can do here also, that there is something called as verbosity in Foundry, which can easily track all the state changes that has been happened during the execution of the test, like this. As you can see, it first transfer, there is an emit called transfer. After that, transfer form has been called, and this process is being done, I don't know, 1 2 3 4 5 6 times, and that's how you can implement this. With that being said, it is the end of our video. Stay tuned for the next challenge walkthroughs.